All right, here we go. We're going to do a few more problems. This will be for special type only. And we'll begin with our example. Special type has to look like this. So, for example, we might want to divide. Let's say we have a 4x cubed minus 3x squared plus 2x minus x. Whoops, we don't want that extra x in there. We'll say minus a 3 divided by, let's say, an x minus 3. Okay, so here's how we do it. The setup is important. We take only the coefficients in here. We have 4. Leave yourself a little room, little space. 3, 2, and minus 3. And then next to it over here, I'm going to write a little corner here, and I'll put that 3, this 3. I'm going to ignore the minus. Okay, I like the minus there, and I'm going to take a 3 only, put it over here. I'm going to draw myself a line across here. Then I'm going to move this 4 down here, bring it down. Then I'm going to multiply this times this. 3 times 4 makes 12, and I'm going to put it over here. Okay, now you can run through that, repeat that a few times if you need to. You can replay this, back this up to see what I did. Bring the 4 down, multiply 3 by the 4, put it over here. Now you're going to add. This makes a 9 here. Now you're going to repeat that multiplication here, across this way. That makes a 27. You're going to add again. So notice the same thing that we did before. We're dividing, multiplying, and adding. But we don't have to worry about the opposite thing. Okay, we're just adding. The opposites are taken care of for us. So this is a 29. One more multiplication here. Okay, 3 times 29 is what? 87, right? And put that over here. Okay, 3 times 29 is 60, and 27 is 87. Do an addition here, one more adding. That's an 84. That last number that we get there, we're stopped. This is our remainder. And we write our answer as this. Now notice when you're dividing by a power of 1, this is a degree 1, it will lower this by the quotient will be 1 degree less than this. And that will start off with a 4x squared plus 9x plus 29 plus 84 over the x minus 3. Okay, so it's a nice process that eliminates a lot of variables and carrying down and dragging around, and reserves that for the end of the problem where we put the variables back in. This process, it's called synthetic division, and it really shortens the work we have to do for many problems of this type. Let's do another example. Let's find 2x to the 4th minus 3x squared plus x minus 1. And we're going to divide that, say we're going to find this quotient. We're going to find this as an x. I'm going to make this minus 2. Okay. So, okay, so let's start. Set up. I have x, whoops. I don't want that. I want just a 2. And now I'm missing a term in here. I did that purposely because in synthetic division, it's not optional. You have to think of that as 0x cubed. So I would literally put a 0 in there. Then I would move to the minus 3 because the x cubed term appears to be missing. But that's okay. Then I would put a 1 for the x and a minus 1. So I'm only interested in those coefficients, and then put a 2 out here. Okay, draw your line, drop down that 2. Begin multiplying. 2 times 2 is 4. Put it over here. Add. That's a 4. 0 and 4 is 4. 4 times 2 is 8. Put it over here. Add. That's a 5. 5 times 2 is 10. Add. It's 11. 11 times 2 is 22. Add. It's a 21. That's your remainder. So your answer now, your quotient looks like this. 2x to the third. Notice I started with the 4th power. I'm down to 3 now. Plus 4x squared plus 5x plus 11, and then plus that remainder 21 over the original x minus 2. Now that's fast. You think about how many steps it took to do that before. Okay, in the last section, that's our standard long division algorithm. Take us forever on that. Now, this does not replace long division because this, remember, this only works on the select type of problems that I've shown. We could not do that for a problem like this. Let's say we had x to the third minus 3x squared plus an x minus 5. If you were dividing that by, say, x squared minus 2, for example, you couldn't use. Okay, this one, no synthetic division. Okay, no synthetic division on that. Not allowed. It doesn't work. Okay, it's only when you have first power in here, x. You'd have to have, see, that's what's wrong with there, with that one. That's not a 1. It would not work. Okay, so you have to know when this can be used and when it can't be used. Let's just do one more, and then we'll call it quits on this section. Let's find this quotient. Let's do x to the 5th minus 3x to the 3rd plus x minus 2. And we're going to divide that by, let's do x plus 1. All right. Now, first thing is, notice 1, we're missing a term in here. That's a 0. We do have a minus 3. We're missing another term in here, the x squared term, so that's another 0. Then we do have a 1 for the x, and we have a minus 2. Now, what goes over here in that little corner is not a 1, but a negative 1. Okay, see, our divisor has to look like this, x minus a number, c. So if your divisor starts off with x plus, then you have to view it as x. See, in this case, we view it as x minus a negative 1. This way I can take my c and put it in over here. This is c. All right, so that part is a little bit tricky, but if you just make a mental note, if it's a plus, then you're going to have to put in the opposite of that 1. Now everything else is the same. Bring down the 1, multiply, that's a negative 1. Add, multiply, add, multiply, add, multiply, add, multiply, add. There's our remainder, our answer. All that, not a lot of work. Started off with an x to the 5th, so we must be down to 1. See, that's the 1 now. X to the 4th minus 1x to the 3rd minus 2x squared plus 2x minus 1, finally minus 1 over x plus 1. We put that back into that form. So tremendous amount of time saved on that with our new synthetic division.